Vamos a mais uma aula de aerodinâmica. Effects of atmospheric disturbance. Alright. Winds. We have steady winds, then the variable gusting wind, then vertical movements of the air. Alright, so two kinds. Steady winds, gusting or variable, and vertical. We have to take into account the actual conditions and the effects that the variation, particularly of temperature, humidity, pressure, and density, will have on the aircraft's performance. The performance is measured when the aircraft is tested, and the flight manual has performance charts for the effects of these changes on your aircraft. Well, performance is measured by the manufacturer. Wind is moving air. Well, genius. We'll change aircraft flight path. Is measured by speed, airspeed, direction, attitude, and heading, where the aircraft is pointing, altitude, and rate of climb or descent. It will differ the heading and track. The difference between where the aircraft is pointing and where it is going is called drift. We talked about that and navigation as well. Wind during taxiing. There may be specific control techniques to keep the weight on the wheels and to maximize control on the ground. Well, I took the image of my book. Well, here you can say, see on the top, the aircraft is facing towards us, and it is receiving the wind actually from its right side. So it's putting there, putting the aileron towards the right, and that's it. Well, oops. No. Wrong. The first one is receiving on the right, left, on the front left side. So yes, it is putting the aileron towards the left. I'm sorry. See, on the next one is receiving on the left, but rearwards. So it does keep the aileron to the left, but now it's putting the elevator down. And here, and the last one is it has it is putting the rudder towards the left because it is being pushed by the right, so you're trying to correct. Probably this one here is on, it's like is moving. He's trying to start, it's rolling. The last one, this when it shows here the weather cocking tendency. Yes, because you're pushing the keel of the aircraft, so it's spinning. When on takeoff, all aircraft of all sizes take off into the wind, against the wind if they can. Well, yes, I like this, if they can. It's really important to take off into wind. Winds against us is called headwind, and with us is called tailwind. If the wind is not directly ahead, we call it crosswind component or simply crosswind. On the head or tailwind component affects the takeoff distance, but the crosswind component causes some control difficulties. Each aircraft has a demonstrated maximum crosswind component that has been established by the test pilots. So here, as well, I took from the book, the difference it makes whenever you're taking off in still wind, headwind, or tailwind. Usually take off faster whenever you have a headwind. Wind during the climb. Climbing into headwind, the path is steeper ever climb. Climbing with the tailwind, you have a shallower angle of climb. When you need to clear obstacle, climb towards headwind. Do that. When descend approach. Descending into headwind causes a steeper approach. Downwind increases the distance traveled, end up doing a shallower approach. You're gonna have your shallower, you're gonna have your pitch, a smaller pitch. When you have a steeper approach, you're gonna have a much higher pitch. The steeper approach upsets the appearance of the runway and the effects of judgment. The steeper path also affects the landing flare, and the aircraft attitude has to be changed further. It's even harder to see when a higher angle of climb, a higher angle with a steeper angle. It is better to maintain the same approach path by establishing a shallower descent path through the air. Have turbulence, three kinds: mechanical, thermal, and wake turbulence. Let's talk about it real quick. A mechanical frictional turbulence is caused by the wind blowing over and around, through and between various obstacles such as mountains, trees, buildings, valleys, and tunnels. Most of the severe turbulence is in the layer of air closest to the ground, and the energy reduces as you get higher. Mechanical turbulence usually is related to the ground, the lower levels. The air is lifted over the object and then poured down and around the downwind side of the obstacles. You can face significant turbulence and drafts, this British way of writing, on a lee side of a hill. Well, if you have a hill here, you pass, the hill is behind you already, you're on the lee side. All right, guys? Thermal, rising currents of air caused by the uneven heating of the ground. The ground doesn't heat equally. The thermal activity is stronger when the heating of the earth is most active. Early morning and late afternoon are better time to fly in summer. Definitely it is. Usually you only can fly in early in the morning if you're a visual pilot. Late in the afternoon, they're probably gonna face thunderstorms. When flying in turbulence, try to keep the attitude and ignore the pressure instruments. Otherwise, your control inputs may aggravate the situation. You're over controlling, man. The thermals also affect the final approach path. I took this image here. Hope they don't sue me, whoever is the owner. So yes, whichever is on the ground may affect your approach path. Usually with thermal turbulence. Wake turbulence is the wing produces lift. The highest static pressure air beneath the wing forces a flow around the wingtip to the lower pressure area above. We talked that on the last class, previous class. The greater the pressure differential, high angle of attack, the greater it is the flow around the wingtips. As the airplane moves, the wingtip vortices trail behind. Low aspect ratio wings tend to produce wingtip vortices than the long and tapered wings. Wake turbulence normally descend at about 400 to 500 feet per minute and level off at 900 to 1,000 feet below the flight path of the generating aircraft. So you gotta make a calculus. Okay, 900 to 1,000 feet below whatever the path the aircraft was in front of you pass. You're gonna deal with this wingtip vortices, the wake turbulence. A crest wind will cause the vortice to drift off the runway. If you're taking off in the case. Avoid flying above or on upwind of the flight path of the aircraft, producing wake turbulence. If doubtful, delay your takeoff. That's important. You may go uncontrolled. Avoiding the section departures behind the heavy aircraft. Yep, the image shows it all. Thrust stream turbulence. People really like to post videos about that. Is the high velocity air exhausted from a jet engine, jet blast, or jet wash, or the slipstream from a propeller, prop wash. So this jet blast, jet wash, prop wash. You might use that on your exam for explaining. Thrust stream turbulence can be dangerous to a light airplane taxiing on the ground behind a jet or large propeller-driven airplane. Please watch the... See how those stupid guys like to enjoy themselves behind the aircraft? Yeah, they're being blown off. You can see cars, a lot of videos about that, cars, people, everybody being blown off by the jet blast or prop blast. Okay, let's go to the helicopter downwash. Yes, I do talk about helicopter every now and then. Helicopters also produce wake turbulence. The heavier and slower the helicopter, the stronger the wake turbulence behind it. A helicopter hovering when it stopped on the same time as hovering near the runway is a hazardous to smaller craft. Rotor downwash from a helicopter can be hazardous up to a radius of approximately 3 times the rotor diameter. And that's it. End of this class. Bem, aerodinâmica e navegação, as aulas estão bem básicas, bom mesmo para quem está começando no inglês técnico aeronáutico, mas tem as coisas interessantes, sempre você vai revisar um conhecimento como esse jet blast, né, o prop blast, né, você vai você pode utilizar esse tipo de terminologia no momento de conversa durante a prova do Santos Dumont English Assessment e coisas do gênero. Gente, não esqueça de curtir, comentar e até o próximo vídeo. Tchau, tchau.